So once we're here on the lathe, this shaft is 1/2 inch 13 threaded. So we need to make the presser foot that's going to go on here. So I've got some 1/2 inch 13 bar stock, or not bar stock, but threaded rod. So that'll go in here, and then I need to make the piece that's going to press against the material. I think I'll use brass. So we'll match this diameter, and we got to drill and tap for 1/2 inch 13 threads, which I'm going to Loctite the threaded shaft onto it, and then you can adjust this side. I've also got a locking nut that this didn't come with, so you can lock the depth, and that will set how much pressure you're actually going to apply. So let's make the brass feet next. So the feet are going to be 3/4 of an inch long. I'm going to have thread depth 1/2 inch into that. And what I'm just going to do is I'm going to face each one. Call that 0. And pop out the jilch. Oh, as long as I'm at it, it's clean up some of that oxide. These are deep threads because it's 13 threads per inch. It's cutting a lot. Okay, you don't normally need lube with brass, but I think I'm going to try it. Well, I guess it does matter because that's a lot easier. I think that's the end. There we go, there's one. We will make 2 more. Before we Loctite these guys, I'm going to remove all the oil from production off of them. Some isopropyl, always keep in the spray bottle. This is a misting bottle, so it does a really good job of getting into all the nooks and crannies because the mist is pretty small. I've already cleaned these guys. Now these guys are clean, ready to go. Wow, this comes out fast. That is way more thread locker than I wanted. Threads are a little tight. So what I'm having to do is put the threads in the vise. I have copper jaws. Actually, this one's pretty good. Then I take these pliers that are soft face here and give it a good crank at the end. I estimated the length on these guys, but they still have to have a lock nut on here. I think that'll still leave plenty of thread engagement. For full strength threads, you only need 4 to 5 threads. So we'll have more than that. We'll probably have 8 to 10 threads. So we're well past full strength. These guys get some nuts I just purchased. They were pretty reasonably priced on McMaster, otherwise I was going to have to make them. These are thin nuts. Yeah, that'll be plenty of threads engaged. All right, I could have gotten away with a little bit more because there's room for 1 inch of threads internally, and we got 3/4. It would have been 1 inch with the nut, but I knew that going in. So yeah, that'll be fine. Yeah, they're all about 3/4. All right, moving on to the next part. Next up, I got to make the spacer blocks. I found some tooling plate that's 1 1/8 inches thick, which I never thought I'd find in a million years, but I did. So this is already the perfect thickness. I don't have to do any work there. Just got to cut off some 2.5 by 3 inch sections. So I'm setting this line to 3 1/8, and the way I scribed that line was this interesting little tool that I found. And it's got a flat spot over here and a flat spot on the end, so you can set up the depth and then just scribe it. It's kind of weird though. You would think 0 would be this point over here, but it's not. It's some weird, this is like 1 3/32 or some weird thing, and it's probably even metric, but still very strange. I think I would have designed this with 0 reference to be this edge here so that you could easily set this distance and then use this flat section here to scribe a line. Seems very handy. It's also, you know, it works this way too. It can hook that direction by taking this part and flipping it on the other side. So it's handy. It's just not set at any weird normal point. Again, maybe metric, but I did buy this in the United States. They even have vernier scales on here to get the accuracy down to 1/28 of an inch here. I don't know if you can see that, but anyway, it's kind of an interesting tool, not terribly expensive. So don't remember where I bought it though. It was one of the woodworking sites. If I figure it out, I'll put it in the comments below, but I don't think I'll remember, but we'll check it out. All right, so I thought I'd save you the trouble showing you dimensioning these blocks, which took longer than necessary only because I screwed up one. I thought I could fit 4 across one piece of that, and it turns out that if I was leaving my 1/8 inch extra so that I could remove it and square them up, that I didn't, and I only added 2. Anyways, I screwed it up, so I only got 2 out of the blocks. I had to go do a whole nother piece. So we have 3 matching blocks now. Not these need to be precise at all. It just was bugging the hell out of me, so I did it. Now we're going to drill 4 holes in each. These are spacer blocks, and this is just a clearance hole. This is very straightforward, not terribly exciting, so I'll probably abbreviate this. I've loaded 2 blocks at a time. Everything's referenced off of this. This block is just to keep the vice jaws from canting as I tighten on one side. Everything's based on center line, so it doesn't matter about the outside edges. That's 1 done. 1 down, 2 more to go. So I've got my rotary table to do the curve on this big chunk here. We're gonna do the curve right up here. In order to center the rotary table, I'm using a Max Grant over at Swan Valley Machine Shop. Go check him out, he's an Oz, and he just showed this technique of using an indicator around the quill, just put with a mag base and rotate. And technique works pretty well. A little bit of effort, but make sure that your quill is well oiled because you really don't want to scratch it or cut into it. But we got it centered pretty well. And now we're going to go about mounting this piece, which is going to be a bit challenging, and I'll bring you back as I get farther along. You can see how this is mounted. Actually, what I've forgotten is to put in my 1/2 inch spacers, so my bolts are actually too short. However, this is what's going to happen. The center pin is going to be in here. That keeps the center point of rotation aligned and gives us something to press against. And these 2 guys are screwed into the T-nuts in the slots on the rotary table. And we're going to be taking the curve and we're going to be taking it out of this side right here. Right now the quill is dead center over this, over the center of rotation. And we'll be moving 5 3/8 inches out here and just making a curve out here, which will just barely touch at the tip here and should cut off the corners here. So I need to go out to the store and get some bolts. I have a ton of bolts, but not the right size, of course. So I'll be back. All right, so I went out and picked up some 4 inch instead of the 3 inch. Now I can put the 1/2 inch spacing material underneath. Hopefully it'll give me, I'll have enough range. There we go. That's good. So this is on all sides of where these guys are, and now I can just clamp these guys down. First, I'm going to make sure that this is square. So we need to rotate this guy over here, like so. And then we need to make sure that this is square back here. Set my 0 degree marker, which is going to be, my reference point's going to apparently be over here somewhere. And once I get that lined up, then we can just rotate this set amount of degrees and we're good to go. I'll bring you back. Alrighty, so I ran an indicator back and forth from the center pivot point out to one side, made sure that it stayed 0, which means that this is perpendicular. That will be my 0 degree mark. So here, there is a built-in mark over here on this side, but that's sort of worthless because right now it's pointing at 31 degrees. So instead, I find 0 over here and just put a piece of tape and line it up. That way, later, when I have to cut an angle right here, I can just rotate it based on this reading and be right on the spot. The only reason to do this squaring section here, since I'm just going to cut a curve out here for the first part, is because I need it later on when I cut the straight parts here and then go off at an angle out there. So that's why we did that. So this is all tightened down now. I switched to smaller washers because I need to remove something like that, like about 1/2 inch, 3/4 of an inch of material off each side. And that's it. So I guess we're going to get on to milling. I don't know if you remember the leather I bought a while back. This is still one of those pieces. Use it all the time. This one is a fairly thick piece, and I use it especially when I'm changing end mills. I put it underneath the end mill because I've had them fall out when I wasn't ready for them to do so, when I was tightening them up, and chip the corners. And this is a great way to protect it in case it falls. It won't damage the end mill, at least immediately. Sometimes you don't, you get unlucky and they still screw you, but still better than it was. So anyways, that's the spiel. You're trying to visualize what we're trying to do here. We're going to try and machine off that corner and that corner, make this round, and then we're going to try and do the ledge where the blue line is right there, and we're going to cut that one going in, and that's where the piece will actually sit on that wedge. The webbing piece will sit on that ledge and be pressed down on the top by the part that screws into these 3 holes here, the press plate. Although they give that thickness with a huge range tolerance, like 16 thousandths. So I have a feeling they're going to have to use shims or something like that when they're doing this, which is kind of crazy. But anyways, that's what we're going to do. So now we're going to take, we've got my X0 locked off. I've got my milling table locked off. And now we're going to go forward 5.1875, which will put the milling cutter dead center over it. 5.1875. And that'll put the milling cutter dead center over this. Now I need to compensate for the extra 3/8 here. And that puts it at 5.5625. And look at that. What a fit, huh? That's my 0 point. So I don't think I can take it all at one chunk. So what I'm going to do is I'm going to go out a bit further. Well, that's as far out as I can go. And we'll see. I don't know. This may be too big a bite. We'll see if we can take off that much. That's a pretty darn big bite. Unfortunately, I didn't plan ahead. And if I move my milling head out so that I can reach, if I move the whole head assembly this way, or that, sorry, towards the back so that it would actually fit, I'll lose my 0 point and I'll have to calculate it all over again. I don't know. This is a 3/4 inch end mill. This is kind of, everything's kind of leveraged out. This may be a big mistake doing it like this. I guess I'm going to try and see if I can go very gently and have it work, but I have a feeling it's going to be a total failure. If that's the case, because that's as far out as I can go now, I am going to have to move the milling head back that direction. And if I have to do that, then I'm going to have to refine my 0 point again, which is doable, not impossible. But I'll see how difficult this is going to be. Maybe if I took a lighter cut, you know, that could be another solution. I could just lower this guy down and not take a big bite and do this in pieces. Let's see how that works out, instead of using the whole edge of the end mill. All right, what the heck, huh? You only die once. I'm thinking that's not going to work too well. Nope. Even with a little bit of braking on, it was vibrating all over the place. No. I think part of the problem here is my rotary table is a Schar's and it's fairly inexpensive, and I don't think it's very good. Yep, look at that. And I think it just broke my end mill, no less. That was a 1/2 inch end mill. Yeah, there's just, look at that, there's play in the frickin' rotary table. I just sheared a whole tooth off my end mill. Unbelievable. So I'm doing this now conventional milling style with braking on because there's so much lash in this damn thing. I'm just wondering how big a bite I can take. So that worked out okay. It struggled a little bit. Well, this appears to be working very slowly, but it is working. Keeping constant force on it is actually helping. Once I don't have to take a full bite anymore, I'm sure that's going to help a lot. But this is going to be a painful process, I can tell you. Next pass, trying a smaller bite. Only engaging the bottom 1/4 inch or so, which is going to require multiple passes. Still not going very fast, but better than the previous. Not a great finish at all. Of course, this is a coarse roughing end mill.